Now remember we got these general procedures, so we're going to go first and see what's going to be the analysis point. The problem says the rectangular plate is supported by the brackets A and B and by the wire CD. Okay, let's see if I can make it a little bit bigger. So here we go. Now we got this plate that has certain weight. Right now it doesn't matter. Now this plate is being supported by brackets A and B, and we got a cable attached at point C that goes all the way along. Let's see if I can have a different color for that. Goes all the way along from C to D. Now this cable will prevent that this thing to fall. That tells me that these two brackets are not enough, and not only that they will actually allow for a motion like this. That means if I cut off this cable right here, this thing might actually fall down a little bit. So that's understanding what's going on with the problem. Now, it's giving me some important information. I know the cable goes from Z to D. That means that at some point I will actually require the vector that goes from C to D. Now, knowing that the tension in the cable or in the wire is going to be 200 newtons, determine the moment about A. Now, this is an important piece of information. It's telling me the moment is going to be analyzed in here. That means I already know what's going to be the center or the origin of my system. Remember, we like to place our system's origin at the analysis point. That will make things easier. So, knowing that, here, let's see if I can make it prettier. Here, here, like that. Here, here, it's going to be our origin. That means this is going to stand for Y, this is going to stand for X, this is going to stand for C. That means all the motions along this direction is going to be for C, or the motions or the displacement along this direction is going to stand for Y, and all the motion or displacement along this direction is going to stand for X. Knowing that, we can now go and set the locations. Remember, to start building vectors, we are going to need the locations of the different points that compose that vector. First location we're going to need is location for A. However, that one is easy since A is located at the center of my Cartesian plane. We can say that the location for A is going to be 0, 0, and 0. Now, we go for the location for the other relevant points, which are going to be point D, point C, point D, and what else? Well, I think that's pretty much all. So, location for the point A, we already know it, 0, 0, 0, since it's in the origin. It looks ugly, like that. Location for the point C, well, we see that the point C is kind of displaced this much in X, which is turned out to be 300 millimeters. Now, we know this is 300 millimeters. However, the equation for moment is actually given in meters. So 300 millimeters becomes how much? Exactly 0.3 meters. This one right here actually stands for 0.08 meters. This one is 0.24 meters. This one right here again it's 0.08 meters. And this one right here stands for 0.24 meters. Knowing that, we can now set the directions in meters. So A, it's displaced this much in X. it displays this much in C, and it is at the same level of A. That means we will have positive 0.3 in X. We will have 0 in Y since it's at the same level of A, and we will have this displacement that stands for this one right here, which is 0.08. 0.08 in C. Now, as for the D will have this much displacement in X. Well, actually in the same line of C, that means we got a 0 displacement in X. We'll have this much displacement in Y, which is 0.24 meters. And we'll have this much displacement in C, which is actually 0.24. That's it. We got the locations of the different points.